Since the days when students used slate boards, the core dynamic of the classroom has relied on a constant loop of instruction and evaluation. Teachers have long needed a way to measure what their students actually know. The entire purpose of any educational assessment is to allow an educator to make a defensible, accurate inference about a student's cognitive status. You test a sample of behavior to deduce the whole. For over a century, the strength of an assessment rested on two psychometric pillars. First, validity, the accuracy of score-based interpretations. Second, reliability, the measurement's consistency. But in 2014, a revised standard formally elevated a third metric to that same tier of importance: fairness. Proving fairness requires hard data. Test developers must collect judgmental evidence, like independent bias reviews, and empirical evidence, using procedures like differential item functioning to detect if specific subgroups perform differently on certain questions. A valid inference requires evidence regarding all three conditions. If an assessment lacks validity, reliability, or fairness, it fails its primary objective. The challenge for anyone designing a test is ensuring that a correct answer is a reflection of mastery rather than a student's ability to exploit the test's structure. This waveform shows how structural flaws in test items create psychometric noise. When an item contains ambiguous syntax or structural shortcuts, it introduces static that distorts the actual signal of cognitive mastery we are trying to measure. If an item contains internal hints, unknowledgeable students can deduce the correct response without possessing the target skill. To isolate these leaks, we must look closely at the architecture of the questions themselves, performing a microscopic autopsy on individual items to see where they fail. Every multiple-choice question has two anatomical parts: the stem, which presents the problem, and the alternatives, which include the correct answer and the incorrect distractors. Consider this specimen. The bird in the story was an, followed by four options: falcon, hawk, robin, and owl. The article "an" acts as a phonological bypass. A student who never read the story knows "an" must precede a vowel, pointing directly to owl. This structural failure narrows the assessment to basic phonics. The story's actual content becomes irrelevant to the resulting score. To prevent this, professional item writers practice stem stuffing. The stem should consist of a self-contained question or problem. A student should understand what is being asked before even reading the options. When the architecture of an item leads a student to the answer, the assessment ceases to measure the student's true cognitive status. Binary choice formats, like true-false questions, have been used to evaluate logic since antiquity. Their main vulnerability is mathematical. With only two options, a student has a 50% chance of guessing correctly by pure luck. But they have another vulnerability. Look at this statement. Leaders of developing nations have tended to distrust leaders of developed nations due to their imperialistic tendencies. The flaw is the pronoun their. It's unclear whether their refers to developing or developed nations. This creates an ambiguity trap. A student who understands international relations might answer incorrectly simply because they guessed the wrong referent for that pronoun.
By penalizing a student for linguistic confusion rather than a lack of subject knowledge, the item violates the standard of fairness. In an attempt to increase difficulty, item writers frequently insert negative qualifiers into statements. This often reduces the question to a game of spotting the not. Take this historical true-false prompt. The League of Nations was not formed immediately after the conclusion of World War II. It existed prior to the war, making this true. But the interaction between not formed and after forces the student into unnecessary cognitive gymnastics. An assessment is not a venue for complex syntax. Convoluted, clause-laden sentences distort the measurement of knowledge. Historically esteemed novelists known for their elaborate prose would likely construct terrible test questions. Eloquence obscures the signal. The rule is strictly functional. Use clear, straightforward vocabulary. Using advanced verbiage creates an artificial barrier to entry. Stripping away linguistic complexity guarantees that a test measures a student's actual status rather than their ability to decode difficult prose. In recent years, global disruptions, particularly the physical isolation of the COVID-19 pandemic, fractured traditional testing regimes, rapidly accelerating a shift to digital assessments.
To track and close the learning gaps that emerge during this period, educational systems turn to algorithmic solutions. The most prominent of these is computer adaptive assessment. As a student answers questions, an algorithm immediately adapts the difficulty of the next items based on their previous responses, promising more accurate measurements in less time. But for this digital sorting to function, every item must be tethered to a single broad variable, known as a unidimensional trait, like a student's overall reading capability or general math mastery. The efficiency of an algorithm is impressive, but computer adaptive technology alone does not inherently guarantee an assessment is valid, reliable, or fair. Because adaptive tests optimize for that single broad trait, they often sacrifice depth. They frequently fail to offer the granular, student-specific diagnostic data that a teacher actually needs to adjust instruction. Furthermore, because the algorithm routes individual users down divergent paths, no two students take the exact same exam. This makes it difficult to explain results to parents based on questions they've never seen. This flowchart demonstrates how these tests actually work. The touted item-by-item adaptivity is frequently an illusion. Many systems use a cluster adaptive approach, recalculating only after a student completes a batch of 5 items. This batching dilutes the promised precision, reducing the responsiveness of the assessment. High-tech delivery mechanisms do not grant immunity from psychometric scrutiny. Educators must evaluate algorithmic testing just as rigorously as paper exams, demanding evidence they are suitable for local instructional decisions. Whether you are examining a single true-false question or auditing a statewide digital testing regime, the mandate remains the same: protect the integrity of the inference. By mastering the architecture of specific items and understanding the limits of automated algorithms, educators ensure their assessments serve as clear tools for measuring the mind, rather than just sources of noise.